Good afternoon, ladies and gentlemen of our two honors. Good to have everybody here today, except for Balin. But Balin is going to be able to do what today?
Watch on.
Yeah, okay, Balin. So Balin, if you're out there, I hope you are. And doing good day.
George calling him out like that.
No, that's fine. Okay, anyway, consider the interval. We went through this yesterday, right?
Yes, sir.
Represent the interval using interval notation. We have greater than negative infinity, less than infinity. We have, next one, what numbers are in this interval? All real numbers. And what was one way we had of writing all real numbers? Do you remember that?
The R with the R.
Yeah, kind of the script R like this. So we could do that. And what do the intervals, these intervals have in common? What makes them different? And we talked about what those are. And so we talked about this 0 to 5 would look something like this. Would look like 0 to 5. That would look like this, right?
Yes.
And the next one would look like, what would this next one look like?
Open circle on the
Yeah, the open circle on the far right. So it looked like this, this, and then the last one is going to be 0 to 5. Both will be like this. And what kind of intervals do we call these, or these? Finite intervals, right? Very good. So we have that. And that's pretty self-evident. So I think the last thing we talked about yesterday was the symbol U represents the union of two sets. We've been talking about this in pre-calculus too. We talked about domain. Simply, and so what do you think this thing represents here?
It conjoins them together.
Yeah, so this represents all real numbers except zero, or you could say except x cannot equal 0, or just except 0, right? So or you could say all real numbers, comma, but x, sometimes you'll see it like this, x cannot equal 0, all real numbers except x cannot equal 0. So there are different ways you'll see of writing this. I don't like this one as well. You'll see it sometimes because it can be a little unclear what that comma refers to. And these things are, if you don't understand what that comma is, these are kind of contradictory statements, aren't they? So just kind of watch out what you're doing. And okay, so now this is where we finished with that yesterday, right?
Yes.
So now we have the domain of the function f of x is the set of input values x. The range of the function f of x is the set of output values f of x. So the set of input values is x. The range is the output values f of x. So now we're talking about function notation, that x and f of x. Does that halfway make sense?
Yeah.
Okay. So we're going to actually look at some problems for that here. Okay. Hold on. Back there, okay. Okay. Now we're addressing end behavior. Okay, the end behavior of a function describes what happens to the f of x values as the x values either increase without bound, which means approaching positive infinity, or decrease without bound. For instance, consider the graph of the linear function shown. Now, what this does, this brings to your repertoire of mathematics something that's probably brand new to everyone in here. And that is that in mathematics, when you go and observe a graph, which way do you go when you look at a graph? You go which direction?
Right.
Rightward, left to right, or rightward, right? So that's what we do. Now, when you look at end behavior, there are two ways to look at end behavior, and that's as x approaches what? Infinity, or as x approaches negative infinity. And so you're actually, when you approach negative infinity, you're going to be going which way? To the left, right?
Yes.
So just for that evaluative purpose of end behavior, you're going to go to the left to see what's happening there. Does that make sense?
Yes.
Okay. So we're taking a look at the beginning, and then we look at the end. So end behavior has both directions involved. How's that desk working out for you?
Pretty good.
This works better than the chair.
Okay.
Yeah, it is. That's a lot more comfortable.
Bailey's not here, so you can sit in the seat.
It's fine.
Yeah, that's
I
true.
can't sit in
It's
my chair.
pretty. Well, the thing about it is like,
Yeah. Do we need to write all that down?
this thing right here, that might be helpful. And we're going to go into the notation. Okay, so let's go ahead and do this. It says, consider the graph of the linear function shown. And I'm just going to go ahead and do it with this. As we're going in this direction, as x gets bigger, what's happening to the value of the function? Increasing, right? So the way we would articulate this, we would say as x is approaching infinity, comma, f of x is approaching what? Infinity also, right? So this represents our end behavior as x approaches infinity. And then, as we say, as x approaches negative infinity, what does f of x approach? Also negative infinity, right? So that's just looking at the end behavior. So that's how we would write it down. And when you go into pre-calculus next year, hope most or all of you go into pre-calculus next year, we're gonna go from this notation to yet another notation that also I hope will be pretty simple for you. Does this look pretty simple?
Yes, sure.
Okay. You go ahead, and what I'm going to do is erase this for our 7th period friends.
You have a class in the seat?
Yes. Which is another Algebra 2 honors class.
Which class you like better, this one or that one?
Which one's more fun?
Man, there's just a lot of it. You guys are all fun. That's a good class too. Because remember I had you guys sing yesterday for that? Both you guys were just excellent singers. The one thing they had though, the one thing that this class has, the other class doesn't have, it has more people.
Character.
Personality.
It does have some personality too. They have some personality too, but
Just kidding.
you have more people. So that's helpful.
How much?
Not that much. You got a few more people. Well, see, Maverick knows what that's like. He used to be in that class.
Mary, how much more people?
It's pretty full too.
Yeah.
It's pretty full. So this one has 20 people. That other class has 18, I think.
Bigger, better.
Wow.
It says 20, 18. Okay, so here's a little, you can write this down as notes right here. It's kind of this table of end behavior.
Can you zoom out?
I can zoom in a little bit probably.
So they both, if one goes infinite and the other one goes infinite.
So that's probably about as, let me see, I'm going to try to zoom a little more. That's about as big as I can zoom it right there. Yeah, that print here is pretty small, isn't it? In the back. What I try to do for graphics is I find that if I use initially 24 font, it's usually pretty legible from anywhere in the classroom. This one here, to make space, I probably made that like 18 font or something like that, which is not as legible from a distance for people who are slightly nearsighted.
We'll do a straight line.
Or straight up blind? Are you straight up blind?
I am without my contacts and my glasses.
Yeah, I am too. I would have to, if I didn't have my contacts on, I would have to go up within a few feet to be able to read that. That's what it would be. But fortunately, the modern technology of contact lenses, pretty much 2020 in that eye.
I'm almost done.
Okay.
I agree.
What's he saying?
What are you saying?
All right.
Not really confused.
It's just shuffle.
What's that game called? It's called U-Game. No, it said he wants to play with you.
I only know that.
He said he had it outside.
I think he can hear me well.
I'm just gonna check.
All right. So we're going to go over an example problem here.
Do we need to write all that down?
No, I don't need you to write this down because this is going to be like a problem I'm going to give you pretty soon. So I want you just to sort of relax and pay attention here more than anything else.
That's good with me.
Yeah, relax and pay attention, all right?
You get to relax. It's in there.
Okay, so example 1, write the domain and arrange the function as an inequality using set notation and using interval notation. Also describe the end behavior of the function. And we'll do a few of these, then we'll be ready for exercise set tomorrow. Okay, the graph of the quadratic function f(x) = x squared is shown, and there it is. And the domain, and we're going to write the domain in inequality notation. So how do we write the domain of this function in inequality notation? So we write it like this: x is greater than negative infinity and less than infinity. Okay, that's it. What about set notation?
Oh, I have this in my notes. Let me see.
Okay, this is x
X
With
one
that,
such that,
negative.
minus.
X.
Negative.
yeah, you could do that, or you can do it like this. I'm gonna be a little lazy.
Okay, that's fair.
E and then
Okay.
backwards R.
All real, so x is an element of all real numbers. So that was my lazy way of doing it. And interval notation is gonna be what? Negative infinity,
Comma infinity.
infinity. Okay, and then our range is going to be, is our range going to be the same as domain?
No.
I assume not.
Probably not, right? Let's go ahead and look at it.
Outside of 0.
So inequality notation is going to be, for range, is going to be what?
0.
Yeah, x is going to be greater than or equal to 0. And in set notation, it's going to be, oops, I made a mistake, didn't I? What am I supposed to say here?
Infinity.
F of x
Uh,
equals y is greater than or equal to 0.
Hold up. What?
I think you should
Oh,
write
because
this down.
y, oh, down
Right. So that's another thing you have to remember, that you have to use y for range instead of x. Does that make sense?
Yeah, totally.
Yes, sir.
Okay, in the set notation, it's going to be y such that y is greater than or equal to 0. And finally, for interval notation, what is that going to look like? Remember, it's brackets and parentheses.
F of that.
So we bracket 0.
bracket.
So bracket 0, Noah says, right?
Yes.
And then
There's no right about that, go ahead. Comma.
infinity
infinity.
with a parentheses.
Infinity. And then parentheses.
Yep, that's it.
Alright.
Okay? Good job. And in behavior, as x approaches infinity, what does f of x approach? F of x approaches infinity. As x approaches negative infinity, what does f of x approach?
Infinity.
So we're going this way. Which way is f of x going?
Infinity.
Infinity. So end behavior is what? The same no matter which way we go. In this instance, as opposed to the last one we looked at, right? With the line.
What, so it would be negative infinity and both? Or just be negative infinity then positive?
Not for this one. This one is, the end behavior is positive infinity either way we go. It starts from high and ends high. We're going to do this later. We're going to talk about odd and even symmetry. But we say functions are looking like this: odd, odd, even, even. Who do we have? Who are the cheerleaders here?
Oh, lady.
Lady.
Cheerleader. Anyone else? Oh, I'm, or yeah. So you cheerleaders, this has to be it. You have to be odd, odd, even, even.
I'll do
Yeah,
that.
get up there, go get it.
You have
We'll get the
to-
mascot out there doing it for you.
Okay, yeah, the mascot, yeah, you got a great mascot. We have a great mascot, I gotta tell you that. I don't know who she is or he is, but we really have a
She
great.
is him. Who? We don't know.
We don't know, it's like a mystery.
Kind of like it is in Emma.
She's evil.
What would guess that?
Somebody about the same size as Emma.
No, it's crazy, huh?
Crazy.
I mean,
Wow. It's almost like it was built just like Emma.
Okay, next. This one here, is it called example 2?
That's what we call a seed.
And I call it example 1, but it's another function. So I made it a little bit bigger. So this is going to be example 2 right here. I made that just a little larger, okay? Okay, same type of consideration. I want to do this pretty fast. This one right here, we have this function f of x equals 2 to the power of x. What is our domain in inequality notation?
Okay. Wait, could that be negative infinity?
Have you noticed a lot of functions have this same domain?
Yeah, crazy.
Yeah, that is crazy, right? Are all functions going to have this domain?
No.
No. But by my experience, most of them have this. And set notation is going to be x such that x is element of all real numbers. Interval notation, same thing, right? And what is our range going to be?
Same thing, negative.
Same thing as last time.
Let's look at last time. Last time what we had is x is greater than or equal to 0, right?
Yeah.
Is this the same thing?
No.
No, it's not. How is it different?
Because there's a negative. No, it'd be.
Okay, x is actually greater than 0.
What if you,
Oh, it is what? Who said that? Oh, very good. Good call.
You should get a star.
Well, again, you should give her a star, but you didn't.
When I get a new paper, I'll do that. Y is greater than 0, right? Thank you. Okay, set notation. Y such that y is greater than 0. Finally, interval notation. There it is.
there she goes.
Now for end behavior, as x approaches infinity, what does f of x approach?
Infinity.
Okay, so that's one end behavior.
That's.
And now we have as x approaches negative infinity, what does f of x approach?
0.
Okay, Noah says 0. Oops, let's see, did I write this wrong?
Should that be infinity?
Yeah, there we go.
This should be infinity here. 0. It said something, wrote something different. There we go, that's where it is, right? Okay, thanks. Okay, you see the distinction here? As we go up, as we go to the right, we're approaching infinity. As we go to the left, we're approaching
0.
0. Okay? Is this confusing for anybody?
No.
No, I'll catch up.
Yes.
I might ask some questions. Once I get it, I'll get it.
I understand the range, it's the range I'm having trouble.
I just don't know what notes to write down. There's like a lot of
Domain?
stuff.
The main's the easier part, I don't understand the range.
Oh, the range is harder?
Yeah, I don't understand.
Well, to me, what happens is, algebraically, the domain is a lot easier to figure out. The range, sometimes you have to just look at it. And eventually, when you get to pre-calculus and calculus, there are going to be techniques you have for determining what and there are some we're going to explore here in Algebra 2 Honors too, but yeah, to me, range is harder too. And it's for that reason. Okay, then the question, well, we have a couple questions here. Why is the end behavior of a quadratic function different from the end behavior of a linear function?
Good question. Yes.
Okay, remember, let's remember kind of what they look like. The one we saw, the linear function looked like this, right?
Oh, and the quadratic for you, right?
And the quadratic function looks like, now, the one they had was different. Well, we can do a quadratic function like this, right?
Equation goes to 2 within boxes, quadratic goes to all four. Nice, you know.
Well, here's the thing about it. Okay, now, what if,
Okay, just moved it. What about now? You don't know. Yeah, it's 42.
I give up.
Because it bends.
okay, what it is, end behavior, right? The end behavior is different for both of these, isn't it?
Yes.
Okay, one is like this, right? Odd, or odd,
So the other one's even.
and even,
One's odd, one's
or even, right? Even behavior. We're talking about exactly what it is.
Linear's odd, quadratic's even. I'm way up for it.
So, that's
Okay.
what I want to do. I think we can start working on some exercises today.
Wait, the worksheet?
Yeah, we'll start on this today.
I'll be. I've written down. Can I just
Well, I think that's a new
There you go, man.
I don't think I'm
Calculus
This is your G.
Okay, yeah.
The QR code does?
It's my fault.
It is.
Hey, wanna know what's else?
Oh, is this like we're doing it together?
We'll start out like that, yeah.
Is the QR code for your YouTube channel?
So,
The QR code for your YouTube channel?
yeah, I'm gonna explain that in a little bit. Thanks for asking about that.
Maybe it goes to the YouTube
You need that microwave on the floor, yours?
Are we getting this together?
I hope it is. I hope I didn't steal it.
With his guitar.
I know it's like a school gashi one or something. For like a present.
No,
Are you going to the volleyball game tonight?
I was planning
Hey, I
to
really
go.
complimented the
You going to go to the football scrimmage on
I'm kind
Maybe,
of.
I might.
Yeah, we're gonna do
I don't
this.
Where's it? I'm
here?
I just linked it up.
No, I did it in the.
Yeah, you want it on? Oh, I don't think anyone uses it on here.
I'm just gonna.
They're talking about, they're talking about when you recognize in the back. You take it off. Something.
Five.
That's what they say. As they think about putting it in the back there.
I'm thinking about saying.
Honey.
Awesome. Still gonna.
Okay. So this is the first one, isn't it?
Sure is.
Okay, write the interval shown on the number line as an inequality using set notation, using interval notation.
Can I try to do it on the board?
Yeah, what I'll do is, I think this is the one where I could actually call somebody. Yeah, I could actually call somebody to do this one.
It's okay, James volunteered.
No, I think Lynn should go.
Yeah, I want to go.
I think Jake should go, actually.
We'll call him.
Yeah, I don't think
If you want to do it.
Okay, here we go.
Your host on camera.
No, I just.
So, let's go.
Oh, but you can't be average.
This side one time.
Okay, this one here, we have
Jake's already finished his paper.
Wesley.
Do it. I want you to take a look at it.
Wait, you?
Have at it.
Hold on, I'm thinking about how to do it. Okay, I think I know how to do it.
Yeah, they're tigers.
All right, Wesley. He's not afraid, right? It comes right up here.
Oh, Lord. Oh, my God.
Hey, you've got to write 3 other things up there, so calm down.
EY.
All right.
Okay, that'll be your inequality, right? So
Yeah.
inequality
I gotta do
notation.
all of it?
Well, do you want to do set notation also and interval notation, or do we need to get somebody
I
else?
think we need to get.
Can I do interval notation?
No, I think Kaylee needs to come
Can
up
it
here.
be just x is greater than or equal to?
What about Laney? Laney's sort
No,
of,
I want to.
I want to do the last one.
Yeah, let Kaylee just say.
No, I
that.
don't know how to do any of
I
this.
can do it.
you know,
Just the last one. Can I run up there and do the last one?
Brandon?
Mr. G.
I'll let Brandon.
Mr. G. Could it
That's the
only,
first one listed.
Oh yeah, Brandon with the pig drip check.
Mr. G. Could it just be x is greater than or equal to 5?
Okay.
Hey, you're on the YouTube channel, right?
Yes. Yeah, well, I'll bring that up. Good point.
Is your hair just suddenly?
I really hope this is right, otherwise I'm gonna look real out
This
there.
is the same thing.
You can't see anything because you're holding it, so you can cry about it.
No, I'm just saying, if it is wrong, you can fix it before you show it to the camera.
Okay. Oh, wait. Hey, camera.
As the first one.
Yes, this is tedious, I know.
Oh, I did it on the floor.
Narrating.
Thank you, Brandon. Okay, one thing that Noah said, I want to point out, I thought he made a good contribution here, was he asked me if instead we could write this is, and correct me if I'm wrong, Noah, like x is greater than or equal to 5. Could you just write it like this is what you asked? Yeah, this will be sufficient too. That's an inequality notation that describes the situation. So,
It is a sticker.
okay, yeah, I always people stickers. Yes, do you want to do the last one?
Yes, I think.
She'll do the last one.
I'm hoping I
You're on
do.
YouTube, be careful.
Hey guys.
Hey guys, welcome to another video.
Welcome back to my channel.
Today, we will be pranking. Who? I don't know.
Okay, good.
Good handwriting.
Yeah, it is, right? And
Pranking me handwriting.
Right.
okay, so it's all there, right?
Yes, sir.
Yes.
Okay, good.
Fine, it isn't even.
How did that one be?
Okay.
Oh, Kaylee, you were.
So any questions on that? I'm going to give you guys some extra credit on this. No, I want you to come to class. And here's the thing, class.
I'm alive.
Travis was asking me about the QR codes. You see in the upper right corner is a QR code. The QR code is going to do probably the odd number problems in the set. So it won't do the whole thing. But
So it's like the odd
yeah, the odd number problems. So you could go home with the odd number problems.
So just do odd.
Or you could, right? We're gonna do these in class
Okay, we'll do them in class. Together.
for the most part right now. But
So do we need to do it?
Wait, so we go home and do the odd number problems?
you don't need to, no.
No.
Now what you can do is you can watch the video if you want to.
I'll go home and watch the video, yes sir.
I'll go repost your video and you can be home.
So Mr. G, we don't need to do
I will
anything on the
check
test
out
tonight, do we?
everything I do for the rest of my life if you give me home. Okay? Thanks for the scholarship.
Okay.
If you-
Extra QR code.
You get.
No, I don't need you to do problems at home today, tonight. I don't need you to do that.
Give me that.
Okay, next one, problem 2.
843.
Okay, write this interval
Like,
as inequality and using set notation.
I got it. Mr. G, I think I got this one.
I have.
Can I go there?
The only one I understand.
so what's the least nine?
Yeah, go ahead. yeah.
Okay, 5, 6, 4,
Yeah, so Caden, call it here.
Okay, then, make sure you say hi to the
Do
camera.
you want me to write both of them?
Yeah, well, once you do that, I think that should get us close to the
Hey,
end
you're
of
so
the
close to
class.
both of them,
Isn't that a good thing?
Yeah.
It's supposed to be here.
Sure.
So, it needs to be Oh, good.
We ain't taking no time off.
Oh, no, I didn't do that.
Greater than the bottom of the other.
Look how good Aiden.
You forget the last one.
Forgot the last back brace.
Maybe on YouTube, that's really. Back brace.
No, the back brace
Okay, does that look right?
off. You forgot the set notation.
You forgot the
That is set, that is set.
There's only 2 of them.
Which one's the?
Well, I think you need to
It
get-
only says 2.
You got this.
Already in it.
Yeah, so here they gave you interval notation. And they want you
Wait, so why can it not equal 5?
why can this thing not equal 5? That is a question.
Don't
Oh,
ask.
no.
Okay.
it's already-
No, ask why can this thing not equal 5?
Parentheses.
Because it has the bracket
Oh, this
in the.
Good distinguishing question right there.
Yeah, what?
Now, we are about to the end of class.
I know that's how good that already is.
Set notation, interval notation.
What time do we leave?
I thought.
47.
Oh, we got 2 minutes.
So you got 2 minutes. So,
I can do it in a minute.
one last
Jaylee, go,
One last person here.
Mr. G, Jaylee's got
Jaylee wants to go.
You want to go up there and do it?
You've got 50 seconds. You're on the clock.
Don't worry, I got it.
Don't pick the camera.
Brandon, so Jay.
Oh, Brad, you're gonna be up again. He spins the wheel on his computer. And it just got you again.
Oh, let's
Brad
do it.
Shaw. Brad.
It's like you're the new guy.
Is it negative? I couldn't tell.
I think it is.
Okay, well, there you go.
What I'm going to do is, for people who went today, I'm going to go ahead and take your names off and get other people tomorrow.
But I want to go again.
You want to go again?
Yeah, I like my cars.
There's my problem, all done.
Right, does that look right?
Yeah, that was right.
Who's gonna cause you the stress?
Yeah, it looks good, thank you.
Wait, what's happening?
Uh-oh, we heard already.
So we're just going to leave it at problem 3 today.
Nice.
Sweet.
For this, and we should be able
Okay,
to.
fine by me, fine by me. Hungry.